In this video, we're going to start with the ArcGIS classification. So, when mapping quantitative data, you want to classify the data appropriately so the information is not skewed or misleading. ArcGIS has 7 classification methods. So as we introduce it, in last video, we will restart with manual so we can compare everything at once. So with manual classification, you can set class breaks manually by typing them or by adjusting the histogram break bars in ArcMap. And then for equal interval classification, the entire range is equally divided by the number of classes you choose. If the range of values is 1 to 1000 and there are 5 classes, this method will create classes of 200 for each. So it will be 1 to 200, 201 to 400, 401 to 600, and 601 to 800, 801 to 1000. So it's easier you put it in this way that we have 100 from 1 to 100, and we put for 10 classification, each one is 10, so we will 10, 20, 30, 40, 50, 60, 70, 80, and 90, and to 100. So this method is useful for highlighting changes in the extremes and is most appropriate for familiar data ranges, such as percentages or temperatures. With this method, it is also possible to have classes that contain no values. For the defined interval, a defined interval is similar to an equal interval. However, you get to define the interval size to determine how many classes there are. If the students in your class have a range of test scores from 50 to 90%, for example, and the interval size is 10, this method will create 4 classes: 50 to 60, 61 to 70, 71 to 80, and 80 to 90. Quantile. With quantiles, all classes have the same number of features. This method is appropriate when data is linearly distributed. It can create a balanced-looking map because no classes have too many, too few, or no values. However, the resultant map can be misleading. The key is to increase the number of classes to prevent data from being placed in a different class. When an appropriate number of classes are used, the data can be visually represented more accurately. Natural breaks classes are based on natural groupings inherent in the data, and boundaries are set where there are relatively large gaps between values. Developed by Professor George Jenkins of the University of Kansas, this method is useful for classifying unevenly distributed data such as population. Geometrical interval. The geometrical interval classification scheme creates class breaks based on class intervals that have a geometrical series, such as logarithmic distribution, and this method, Jenkins and back here, this method was specifically designed to accommodate continuous data and minimize variance within classes to ensure that each class range has approximately the same number of values and that the change between intervals is very consistent. Standard deviation is the last one in ArcGIS. Data that you know is normally distributed in a bell-shaped curve can benefit from standard deviation classification. This method creates classes according to a specified number of standard deviations from the mean value. We recommend a divergent color scheme for this type of classification. Now we're going back to the burglary data. So now we have a Berg 2, and here we're going to use the classification is natural breaks. So the burglary 02 attribute represents burglaries for each county in 2002 in Texas. By default, the value in the burglars field are grouped into 5 classes using the natural breaks classification method. So if your color ramp is different from the one for previous graphic, click the color ramp arrow and then click blue light to dark ramp. So we're going to do blue, start with a B, blue light to dark, and then we're going to click the color ramp arrow, and to find the name we already did, we uncheck if we want to look at the color, and we can check it if we don't want it. We want to look at the words. It's easier, just unclick that, and then we are going to do the classification is 5. I think maybe earlier I changed it, and we hit apply and hit OK, and then we're going to zoom to layer. Now we can see the graduate color symbol is applied to the map, and the table of contents is updated to show the values represented by each color. The light colors represent fewer burglaries, and the dark colors represent more burglaries. This may be useful to crime analysts who want to quickly see where the most burglaries are occurring. It doesn't count, however, for how many people live in a county or how many square miles are in a county. You will explore the situation later, but for now we will see how other classification methods affect the map. So the number of counties in each class is different. The class with the highest value has just 2 numbers, Dallas and Harris County, where Houston is. The next highest class also has 2 numbers, Tarrant and Bexar County. The remaining county belong to the 3 lowest classes. So now we go into the table of content and go back to symbology again. Right click on it and property and go back. So in the classification scheme frame, we're going to click classes arrow and then click 3, and we're going to and then we see the number of classes and their value range are adjusted here automatically, and we're going to hit apply, and we see some changes, and we're going to move the layer box and we can see them at the same time. So the map reflects the new classification, and the highest burglary class now contains 4 counties. Many counties that previously belonged to separate classes are now grouped together. There are many so why might these counties have a higher incidence of burglary than surrounding counties? So there are many factors, but one factor is the higher population density in cities located in these counties. So like Dallas, Houston. Okay, now on the symbology tab again in the classification scheme, click classify, so we can see more options here as I showed. So the classification dialog displayed the current classification method and the number of classes. under classification statistic, you can see the count, minimum, maximum, sum, mean, median, and a standard deviation of the burglary 2002 field. You may need to scroll to the right to see median. Now my window shows up everything that we don't have to scroll. In the break value box, you can see the upper thresholds that defines each class. So the percentage sign right here, button displays decimals as percentages. A large window is contains a histogram is right here or frequency distribution chart. The x-axis horizontal. It doesn't show that we can drag it around from here, and it shows the range of values in the burglary 2002 field. The y-axis vertical is a count of features. So vertical blue lines are class breaks, also known as the break value box. The gray columns represent the numbers of features that fall within a specific pan or the total range of values. By default, 100 columns are drawn in the histogram, so each column represents 1% of the total range. In this case, value range from 0 to 39,275. So the total range of the histogram is 39,275. This wouldn't be the case if the number of burglaries began with a number other than 0. Here, 39,275 divided by 100 is rounded to 393. So each column shows the number of features that fall within each span of 393 values. So now we in the break value box, first we click the breaks. Now we're going to put 1564. And many of the gray columns are grouped within the first class. This means there is a high count of counties within fewer than 1,564 burglaries, exactly 228 counties. The count is shown below the histogram window. Next, you will take a closer look at the columns in the histogram. And now you can see the 228. Now right-click the histogram near the origin of 0, where the axis and y-axis intersect, and then click zoom in. We can do that and zoom in. We can zoom in a little bit. And if you zoom into another spot, the histogram by mistake, right-click and click reset zooms, and then try again. So now 5 elements of we can just reset zoom. Your zoom results may be a little different from what you see in my graph. So by zooming it onto the histogram, you can get a better sense of how the values are distributed.